Hello students, in this session I am going to discuss the next properties that is called the ionization enthalpy. In earlier video or in previous video we discussed about the atomic radius and their factors. Today we will discuss the ionization enthalpy. Ionization enthalpy or ionization enthalpy, you can call it ionization energy. Ionization energy. We write in this form del I H, or in short I E. At first write down the definition. The minimum amount of energy required to remove the most loosely bonded electron from an isolated gaseous atom to form gaseous cation is called ionization energy or ionization enthalpy. Suppose we have M gas and we use energy to remove electron, so it becomes M cation and electron removed. Since energy is always required to remove the electron from an atom, hence the ionization energy is always positive, because as we know, nucleus and different energy shell in which electrons are bonded with the strong electrostatic force of attraction. So energy is given to remove the electron, most loosely bonded electron. In this way, when electron removed from it, so energy required. So minimum amount of energy required to remove the most loosely bonded electron from an isolated gaseous atom to form gaseous cation is called the ionization enthalpy, ionization energy. And when one electron removed, it is called the first ionization enthalpy. If two removed, it is called the, suppose we remove one electron, it is called the first ionization enthalpy. If we remove second electron, it is called the second ionization enthalpy. And the units of ionization enthalpy always used in kilojoule per mole. Units kilojoule per mole. This is the simple definition to understand what is ionization enthalpy. Let's see what are the factors on which ionization enthalpy depends. What are the factors? Let's discuss one by one. At first write down the factors on which ionization enthalpy depends. First factor, size of the atom. Second factor, magnitude of nuclear charge. Magnitude of nuclear charge. Number shielding effect we have discussed about in the previous video. Shielding effect, which is also known as screening effect of inner shell electron. Number 4, penetration effect. Penetration effect of electron. And last, the electronic configuration. Electronic configuration of atoms or ions. These are the factors on which ionization enthalpy. Let's talk about the first factor on which ionization enthalpy depend. It is the size of the atom. Students, we know that size of atom increases. Size of atom increases on going down the group. Going down a group. So, outermost electrons attracted towards the nucleus by laser force. So that ionization enthalpy decreases. We can say that atomic size increases, enthalpy decreases, and in period size of atom decreases. Size of the atom decreases due to increasing effective nuclear charge. So, ionization enthalpy increases. In nutshell, we can explain ionization enthalpy in group decreases, ionization enthalpy in period increases. So, that is the reason in group or in the period the ionization enthalpy increases in group, because as we move top to bottom the number of shell increases. As we know that top to bottom size of atom increases. So, enthalpy, ionization enthalpy decreases. But in period, size of atom decreases, so ionization enthalpy increases. In this way, we can learn or memorize the reason. What about the factor on which ionization enthalpy depend? The first factor is the size of atom. Why ionization enthalpy decreases in group, and why ionization enthalpy increases in period. Next is the magnitude of nuclear charge. Next is the factor on which ionization enthalpy depend, magnitude of nuclear charge. Nuclear charge, that means proton in the nucleus. That means protons in the nucleus. Student, as we know, attractive force attractive force between the nucleus and electrons increases with the increase in nuclear charge. Increase in nuclear charge because force of attraction is directly proportional to the product of charge on the nucleus and electron. As the nuclear charge increases, nuclear charge increases, electron attracted towards the nucleus with or by greater force. Therefore, it becomes difficult to remove the electron. Therefore, it becomes difficult to remove electron from the atom, so that we can say that is ionization enthalpy increase with the increasing in the magnitude of nuclear charge. Let's discuss with example. At first, see here. First, ionization enthalpy of second period elements in kilojoule per mole. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. Charge present on means proton present in 3, 4 proton, 5 proton, 6 protons, 7 protons, 8 protons, 9 protons and 10 protons. And the first enthalpy of, if we want to remove one electron, we will provide 520 kilojoule per mole, and 899 electrons when removed from the beryllium, and 801 kilojoule per mole energy provided to the electron from boron, 1086, 1402, 1314, 1681, and the highest is the neon. We will discuss later on why the ionization enthalpy of beryllium is greater than the boron and why the enthalpy of nitrogen is greater than the oxygen, because as we discuss, when we move left to right in a period, the size of atom decreases, so that enthalpy increases. That means the enthalpy of oxygen must be greater than the enthalpy of nitrogen. And when we talk about on the basis of electronic configuration, which is the one of the factor on which enthalpy depend, we can discuss in nitrogen there is a half-filled orbital. So half-filled orbital gives the extra stability to the atom. In that condition, more energy required to remove electron from the nitrogen. Here we will discuss in beryllium 1s2, 2s2. Penetration effect, we will discuss on that penetration effect also. S electron is more penetrated, and also S orbital is fulfilled in comparison to boron. Here is the 2p1 electron. So on the different factor we will discuss later on, the reason for increasing or variations of enthalpy in a respective period. Let's talk about the shielding effect. Shielding effect. Shielding effect of inner shell electrons. So student, in the previous video we have discussed on the shielding effect, how shielding effect causes for the ionization enthalpy increases or decreases. We know that effective nuclear charge is equal to total number of protons minus screening constant. Screening constant is symbolized with sigma b. So simply we can explain in this way: greater is the number of inner shell electron greater is the screening effect or screening constant. As the number of inner electron increases, number of inner electrons increases, effective nuclear charge decreases. The electrons attracted towards the nucleus, by laser force, thus decrease in enthalpy. So the reason for decrease, in short, greater is the number of inner shell electron, smaller is the ionization enthalpy. Now next factor is penetration effect of electron. Penetration effect of electron. For the same principal energy, level or orbit, S electron remains closer to the nucleus, than P electron, P, D and plus s electrons are attracted towards the nucleus by greater force than the p, d and f electrons. So ionization enthalpy for s electron is maximum, and it increases in the order S, P, D and F. S orbital has more penetration, so the enthalpy of S electron will be maximum than the P, then the D, then the F orbital. For example, the first ionization enthalpy of boron, suppose we have boron, the first ionization enthalpy of boron configuration 1s2, 2s2 to p1 is lower than the beryllium 1s2, 2s2 because in boron the electron is to be removed from p orbital, which is less penetrated, so less amount of energy used to remove the electron from the p than the s electron. Similarly, next condition, in case of aluminum 1s2, 2s2, 2p6, 3s2, 3p1, and magnesium 1s2, 2s2, 2p6, 3s2. So aluminum has less enthalpy than the enthalpy than the magnesium, because here electron removed from p orbital, but in magnesium electron removed from s orbital. So in case of p orbital less penetration, so the enthalpy is lesser than the magnesium. The next condition is electronic configuration. Number 1, atoms and ions having stable inert gas configuration like NS2 and P6 have high ionization enthalpy in a period and inert gases have highest ionization enthalpy due to its stable configuration. First ionization enthalpy of nitrogen atom is higher than oxygen atom due to incomplete orbitals are more stable than the incomplete orbital. Nitrogen 1s2, 2s2 and 2p3. As we know, in p orbital, px, py and pz, 2 and 2, total 6 electron. This is the full filled and 3 is the half filled. So full filled orbital and half filled orbital gives the more stability than the incomplete orbital, so that enthalpy of this type of configuration becomes higher. In the next condition, ionization enthalpy or condition of beryllium 1s2, 2s2 atom is higher than the boron 1s2, 2s2 and 2p1 atom, because in beryllium outer s orbitals are completely filled. It is a more stable configuration. So the enthalpy of beryllium is greater than boron. Likewise, magnesium aluminum. Magnesium has outer s orbital and is completely filled, but in case of aluminum, outermost p orbital, so that magnesium has high enthalpy than the aluminum. So students, learns all the factors properly.